we have done the chemical effects of electric current. And apart from that, you can tell the doubts of any chapter we have done until now, like related to sound or light or any from chemical effects or any other chapters, but not biology. uh, for the cells, I have to give it a read. It's been like how many
Okay,
years?
sir.
I have read biology until 10th. Okay, until 10th I have read biology. Then in 11th, 12th, there was no biology, only physics, chemistry, maths. And after that, in 3 years of my graduation, no biology. In 2 years of my post graduation, no biology. So I will take time, but I will make sure that you guys are not left with any doubt. Okay, I am reading biology for my exams. Like I'm trying to attempt UPSC. So for UPSC, it contains biology, and I know all of the basics. I have to read about the chapter which is in your syllabus, like how much content does how much content is there, and how
Sir,
much I
what
have
about
to read.
synthetic fibers and plastics?
Synthetic fiber and plastic. So is this a chapter in your syllabus?
So it's
Sir, it is
deleted
not.
this year
It's
actually.
deleted, but it's there in the previous year grading.
Like in your seventh class?
It's not there in the textbook, sir, but like previous textbook, it was there.
Okay, previous textbook contain. Okay, fine. After we will go through it after we complete the cell. Okay.
I said this. Okay, sir. Uh,
Okay. Can you see my screen?
Yes, sir.
Chemical effects. Okay, fine. First of all, let's go through what we have read in this chapter. Okay, so when we started this chapter, what we started, from which topic we have like uh, did the beginning of this chapter.
So conductors and insulators.
Okay, good. Conductors.
sir, and tester.
Electrolytes.
Sir,
Okay.
testers.
Electroplating.
Sir,
Okay.
Sir,
electrolytes.
first, sir, before electrolyte, electroplating, heating effect of electric current and magnetic effect of electric current.
Okay.
Anode,
Heating.
cathode, electrolysis.
Chemical effects of electric current,
Chemical
electrolysis.
effect and magnetic effect.
Okay, good. Chemical effect and magnetic effect.
Sir, we went through why does the bulb not glow?
Now we went to
Like,
electrolytic cell,
Yes,
anode,
electrolytic.
cathode, electrolytes, and electrolysis.
Electrodes.
sir, good conductors and poor conductors.
Okay, electrolysis. The electrodes.
Electrodes and
Sir, you
Okay.
wrote
What
electroplating twice.
I have, yes, electroplating I have written.
sir, you can write electrolysis.
Yes, electrolysis.
Sir, even you can write LED.
Electrolysis. So yes, we can write regarding LED that we have gone through LEDs. Okay, what is left?
Sir,
Sir,
even
magnetic needle.
electrolysis. Okay,
So the
electrolysis.
basis of this chapter is current. So we have seen about current. Okay, the current, its unit. Can you tell me the unit of current? Sorry.
Ampere.
Okay, it is represented as A, which stands for ampere. We have gone through voltage. Do you know about the unit of voltage?
Potential difference.
Okay, so voltage, we say voltage as potential difference also. Also, and we represent it with V. And apart from these two, there is also resistance.
Ohms.
Can anyone
Ohms.
Opposite.
Ohms.
ohms?
Ohms.
Okay, very good. Resistance represent ohms. This is the simple symbol for resistance. Yes. Okay, fine. Can anyone explain me what is resistance?
So when electric current passes through an object, any substance offers at least a minimum resistance, which resists the flow of electrons. This
Okay,
resistance
so
creates heat energy,
Mhm.
and this is resistance.
And sometimes light energy also.
Okay, very good. The definition by Karthik is good, but it needs some changes. Ashwath, it does not create directly as light. Okay, resistance and light are like
Sir,
different.
it opposes the motion.
Okay, very good. Very good, Manasvi. So, in Karthik, your definition, you should not mention resistance again because you are defining resistance. So, if you are explaining the definition of resistance, so you
So
should not include.
I was just
Sir,
explaining what is
sir, a
resistance.
force that opposes the
Okay.
motion of electrons in a
So,
circuit.
I would simplify the definition more conveniently if I.
very good.
Sir, a
If you are
force that
writing the
opposes the motion of electrons.
yes, good. So, Karthik, if you are giving the explanation of the definition, you could put hindrance instead of resistance.
Okay,
Okay.
sir. Thank you.
So it is the hindrance provided by the material in the flow of electric current. Okay, whenever an electric current flow, there is an hindrance in its motion. There is a oppose, or you can say opposition in its motion, due to which heating effect takes place. And how this heating effect can lead to light. So this is due to heating of filament. Can anyone tell me what is this filament made of?
Tungsten.
Tungsten.
Okay, very good. So filament is made of tungsten. Okay. So this filament is made of tungsten. So I give you two cases. In first case, let me take a higher current. Let's say this is one bulb. Okay, and in this bulb, so we inside bulb we represent the resistance like this. Okay, so this loop represent as resistance which is present inside the bulb, which is tungsten. Okay, the tungsten is in this shape in the bulbs. So when we apply electric current to it, it glow. So I am taking that in one case A and in one case B. In a case A, the electric current which is provided is high, and in B it is low. Can you tell me in which condition the bulb will glow brighter?
Sir,
So
in
high.
A.
A.
A, very good. So in A bulb, the bulb will glow brighter because there is higher current which is flowing through it. And if a current is flown through a resistance, the resistance will provide higher heating effect.
Sir, I have a doubt.
Yes, ask.
So how can heating produce light?
How can heating produce light? So this is the property of this tungsten. Okay, so tungsten is a specific kind of material. When this is heated, when this tungsten is heated, it produces light. Okay, so
Okay, sir.
generally you can, what you say, hmm. Generally you can take a wood, okay, a piece of wood. Okay, fine. When you take a piece of wood, you supply electric current through it. So can you like will you find that wood as heated, like will that wood emit light or not?
No, sir.
No, because it is not that kind of material which will get heated and it will produce light. Okay, so when you provide electric current to the wood, it will stay at some point because it is an insulator. Okay, what is the property of insulator? That the current, it does not allow, it does not allow flow of current. Okay,
Yes, sir.
so you can take one conductor also. So since the iron, okay, since, can you tell me one good example, can you example of conductor?
Sir,
Copper,
graphite.
Copper.
Silver.
Okay, good. Copper, silver,
Iron.
gold.
iron, gold. Okay, so these are example of uh, good conductors of electricity. Okay, so when you provide an electric current, let's say I have taken a copper material, so this is a material made up of copper. When I supply an electric current I, okay, when I supply a current through it, so can you tell whether this material will be will glow or not?
No,
It
sir.
will not glow, sir.
No glow, because there is no property of copper that tells us that while heating it, it will glow. Whereas tungsten, there is a property of tungsten that when we heat
So
this
it has a high
tungsten,
melting point and offers high resistance.
yes, it is other properties of tungsten. Okay, so high melting point.
And relatively high resistance.
Okay, high resistance. Okay, these are some of the properties apart from the glowing. So what this tungsten will do, so tungsten has high resistance, it has high melting point. What does it mean? That when you supply electric current through this tungsten, due to this high resistance, there is more heating effect. Okay, and when this tungsten is heated, it will provide light. Okay, it has high melting point. Can anyone explain what does this high melting point is of any
Sir,
significance?
It takes
So
higher
it can withstand
temperature to
high
melt.
temperatures. It can withstand high temperatures without melting.
Very good, very good. Okay, that means if we provide higher temperature, then also this tungsten will not melt. It will take very high temperature for it to melt. Okay, which is not generally possible. Like it is possible. Have you? Can you tell me any case where you have seen melting of this tungsten?
So
So,
a fused bulb.
Mhm. Okay, fuse bulb. Okay, very good. Fuse bulb. Apart from that, so since fuse bulb does not is not made up of tungsten, the fuse bulb.
Fused bulbs, like a bulb which is blown out, like fused bulb.
Okay, you can take it as an example. Fine. So we can see we have, like, nowadays what we have inserted, we have combined a fuse with the power supply. Okay, we nowadays we have combined fuse with the power supply. So can you tell me the significance of these fuse with the power supply?
So these fuses act
sir,
as
they break
when
the.
a high electric current is passed through the circuit. That is,
Mhm.
the fuse is blown out. The fuse gets melted
Okay,
and it's blown out, so that no other electric passes through.
so this is a fuse, this is a current. So sometimes what happens that in our main
Fluctuation.
supply, in our power supply, sometimes very high current can pass through it. Okay, very high current, high current. Okay, we sometimes say this as short circuit. Okay, in this case very high current can pass. So when this very high current pass through this fuse melt down, this fuse melt down. Why? Because the fuse has low melting point. So this fuse has specific property of low melting point. Can anyone tell me why we haven't used high melting point fuse?
That
So
if we
because if it
provide high
has
melting point, then like more it will have a energy, like it will have a capability to pass more electric current, and um, uh, the appliances may get fused, like they may blast or get damaged. So if they
Okay,
have
very good.
yes, sir.
if the fuse has a low melting point, then it will have only a limited amount of electricity to pass through, and if more amount of electricity is passed, then it will melt and break the circuit.
Okay, very good. Manasvi, what were you saying?
Sir, actually, when it has low melting point, it melts, and due to that, the connection is broken, and so the current does not flow anymore.
Okay, fine. And if it has high melting point, then
The current would continue flowing, which would affect the electronic
appliances.
appliances that we use.
Very good. So we use fuse so that we can protect the electrical appliances which we are using in our homes. So what happens sometimes there may come high current from the main supply, due to which it can damage this high current this high current can damage electrical appliances. So that's why nowadays we use fuse. But earlier, when there was no fuse, so what would generally happen that earlier we had tungsten bulb. Okay, nowadays we use LEDs. Okay, and so today we use semiconductor devices for our bulbs, but earlier there used to be tungsten bulbs. So when there was short circuit, okay, there was a supply with high current. So this high current would damage the tungsten. Why? Because due to high current, the heat generated by it would increase very much, okay, very high, due to which this tungsten filament would burn out, okay, which would eventually damage the bulb. So there are cases when this tungsten bulb can also like fuse out. We say that the bulb is fused. That means the filament inside it has broken, or it has stopped functioning. So we were discussing that the tungsten has high melting point, it has high resistance. It has high resistance, due to which high heating effect can generate. Due to this high heating effect, the tungsten can heated, and due to this heating effect, it can glow. The tungsten has properties that when you provide any energy to it, it starts glowing. Whereas if you use any other good conductor of electricity, it won't glow, because it does not have the other material, the metals does not have that kind of property that by providing energy to it, that it will glow. So tungsten is also a specific kind of element, you can say element. When you will study the periodic table, you will encounter tungsten in your periodic table.
Yes.
Copper, silver, iron, and gold, these are also elements which are present in periodic table.Ine. So before tungsten, okay, is this doubt clear? That some the I think Manasvi have asked me that
Yes, sir.
how. Okay,
Cleared, sir.
okay, very good. Fine. So, okay, fine. We have discussed about resistance. We have discussed about tungsten. Let me ask Snigdha. Snigdha, do you have any doubt related to tungsten and its heating effect?
No, sir, no doubt.
Very good. Ryan, can you hear me?
Yes, sir.
Okay, while I was explaining this, have you joined now, or have you gone through this explanation?
Yeah, I was there. I was like 15 or 20 minutes late.
Okay, very good. So, can you tell me, like, have you understood the heating effect and all the properties related to tungsten?
Yes,
Okay, very good.
everything that and all.
Okay, do you have any doubt? Anyone, any doubt?
No.
So,
No, sir.
uh, okay, very good. So in bulbs, we earlier we used tungsten, but nowadays we use LEDs. Nowadays we use LEDs. Can anyone tell me why we use LED?
Sir, it glows even when weak current or yeah, weak current is passed through it.
No, I'm
It
not
glows
asking about
dimly.
this. Not I'm not asking about the small LEDs which we use in our experiment. I'm asking about the LED bulbs, the LED bulbs which are present in our home.
It saves
So it's because they do not work
electricity.
on the heating effect of electric current.
What? Can you
Is it
repeat?
like they do not? Is it like they do not work on the heating effect of electric current? That they
Yes,
don't
they
have
do
any
not.
fuses. They don't. They're not made of tungsten. They don't make any use of tungsten.
Okay, so how can it increase their use in our homes? Like they must have any useful effect over the like any advantages over tungsten.
Sir,
That's why we are
Sir,
using.
they consume less electricity.
Very good. They consume less electricity and their efficiency is higher. Like with less electricity, less power, they can provide higher uh, the what we say, sorry, high light, the great amount of light with less power supply. Okay, so why we use LED bulbs? Because these are efficient. These are efficient. They provide higher output with an input. Okay, so you, if I need to explain this with the help of an example, so earlier when we had tungsten bulbs, so the tungsten bulb work on the heating effect. Okay, the heating effect, we need to provide current and then the tungsten will heat and then it will glow. So the semiconductor, these LEDs bulb had have a semiconductor plate which like there is a flow of current, so you can assume that it does not work on the heating effect. It work on the flow of electrons in that specific plate. So the earlier the bulbs we used, the tungsten bulbs we used, those were like 100 watt. Those bulbs consume 100 watt power. Some bulbs had 100 watt. So the watt is the unit. What is unit of power? So it is the amount of power which is consumed by a bulb. So the tungsten bulbs consumed higher power, 50 watt, 100 watt. Okay, and these bulbs used to be very bulky and big. Okay, so these bulbs used to be very big. Whereas the LED bulbs which we have nowadays, these are small bulbs. Okay, these are small bulbs, but they can provide the same amount of glow. Okay, if this is emitting glow, it will, this bulb, this LED bulb will also provide the same glow. Okay, so we have advantages that it has uh, it is small. Okay, it cover less space. Okay, it is cheap. Like in order to manufacture these uh, LED bulbs, these are cheap. So how we, I am saying cheap because these bulbs can give higher output as compared to tungsten bulb. That's why we can categorize this as cheap. Because let's say if a tungsten bulb we have, like tungsten bulb is of 50 rupees and this LED bulb is 100 rupees. But if you use this tungsten bulb, this will consume a very high electricity, which in turn will be like itself will be very expensive. Whereas this LED bulb which comes as 100 rupees will consume less electricity. So it, in a long term, it will be less expensive. These LED bulbs also has higher life. Okay, as I have told you that tungsten bulbs can burn out. So this the tungsten bulb does not remain for last does not last for long time. Let's say if a tungsten you have purchased a tungsten bulb, it will last for like 1 year, 2 year, next to next 3 year, 4 year, not more than that. Whereas an LED bulb can last for many years. Fine. So these are some of the advantages due to which we use LED bulbs in place of tungsten bulbs. Fine. Okay. So we have discussed the conductor insulator. We have discussed current, voltage, resistance. Conductor insulator. We have discussed testers also. Okay. Can anyone tell me why we use magnetic testers in our circuit?
Sir,
Determine the amount of current being flowed through the circuit.
Okay. So
sir, by
the
the more deflection, sir, we can understand that current is flowing through the tester if we can observe like the deflection in a magnetic compass brought near it.
okay, fine. So the magnetic compass have needle like this. Okay. So whenever a current carrying wire is brought near a magnetic compass, it will deflect. Fine. So this this compass has 360-degree rotation. Sorry, this needle has 360-degree rotation, and it is very sensitive. So that means if there is even a small a weak current also, if there is a weak current, then also this magnetic needle will deflect. So this will help us to figure out if any material is a good conductor or not. Whereas if we used the tungsten bulb, then the
Why does it
tungsten
get deflected?
Sir, if we use a tungsten bulb, if like if we provide weak current, it will not get heated to the uh,
yes, heated to
temperature,
a
and it
point.
will not glow.
Mhm.
Heated to the
Very
point and it will not glow.
good
So it
explanation.
cannot detect weak current.
Very good. So whereas this magnetic needle can detect current. So why this magnetic needle show deflection? Because it is a property of current which you will learn in your higher classes. Right now, you only need to know that whenever there is a flow of current, it produce magnetic field. So you will encounter this property in your 11th and 12th. So according to which, when a current flow from one point to another, so let's say if this is a wire and the current is flowing through it, so it will produce magnetic field around it. Okay, so it does not matter if the current is weak or high, it will produce the magnetic field. It will depend whether this magnetic field is weak or high or strong. Okay, so this magnetic field produced by current can be weak, can be strong also. So this needle, the magnetic needle which we use, this is very sensitive. So if there is even if there is a weak magnetic field, this needle will detect and it will deflect. And if this is deflected, then we will surely know that there is a current present inside the circuiting. Okay, so to ensure that this needle gets sufficient amount of current around it, so that's why we use a, like in your activities, what is done with this magnetic compass. So they have put,
Matchbox, and
yes, correct.
we can
They
use
have
a
taken
discarded
the,
matchbox and wrap a wire around it, so that a solenoid is formed around the matchbox, and we can put a compass inside it.
yes. So
And
whenever you will use a discarded matchbox, and you will wind it with the help of wiring, a copper wire, sufficient wiring so that this magnetic needle will be surrounded by this wire, and it will detect the deflection. It will deflect when there is a flow of current. Okay, Manasvi, is this clear now? Okay, whoever asked me this doubt, is it clear that how
Yes, sir.
this magnetic needle is showing deflection? Okay, so it is the property of current. When there is a flow of current, it produces magnetic effect, magnetic field, and these magnetic compass are used to detect this magnetic field. Okay. Hmm. Let me. Okay. Do we have time? 7:42. Okay, we don't have time. Okay, you guys can like remind me to explain you about the Bermuda Triangle. Do you guys know about Bermuda Triangle?
yes,
Yes,
sir. Yes, sir.
Okay.
yes,
Do
sir.
you know about the reason why it was so in so much in the news?
Yes.
Yes, sir.
Okay, tell me.
There were a lot of disappearances around that area.
Okay, lot of disappearance. Okay, can you tell me the reason? Do you know the reason?
Sir,
Yes,
scientists
sir.
believe that an asteroid of a high gravitational force crashed into the sea of that place.
Okay, any other? So let me tell you that it is related to that. One of the reason due to which this Bermuda Triangle was responsible for the disappearance was that magnetic field. So I think if you guys are aware or not, so there the compass which we use for to
Yes,
detect
sir.
the north and south. So it is not accurate north and south. It is this compass will show you north and south, which is 11 degrees to the original one. Okay, so the Earth, this is Earth. So in Earth we have north here, south here. But if you use the magnetic compass, so it will show a north here, somewhat here, and south somewhat here. So the
Sir, I have a
no,
doubt. Is it
yes,
because of the tilt of the earth?
yes, it is because of the tilt of the Earth. Because of the tilt of the Earth, the magnetic field lines are like this, which due to which the compass perceives the north as somewhat 11 degrees from the true north. This is true one, and this is from the compass. Okay, so the it is the location of the Bermuda Triangle that